here again, we have the limit of a giant function here. And so again, we're looking for who's going to win. This leading term here, 2x squared, is definitely going to get large faster. We don't care about the 4x. And down on the bottom here, this exponential is going to overtake these lesser functions. So e to the x is going to win for the denominator. So we can sort of approximate this function, just thinking about 2x squared over e to the x. Now, in terms of who's winning here, e to the x is going to get large much faster. So again, this denominator is overtaking the numerator. So if the denominator gets larger faster, then that's actually going to cause the function to approach 0. Because again, we're dividing by a billion pieces. Those are insignificant little parts then. It approaches 0. Okay. So again, this would have a horizontal asymptote at y equals 0. Okay. So if the numerator wins, it goes to infinity. If the denominator wins, it goes to 0. Okay. One more thing to look at. Mad I couldn't get this inside a half an hour. It's really irritating. Okay, some square root functions. Excuse me. I do want to just remind you that the square root of x squared, this goes back to pre-cal, the square root of a variable squared is the absolute value of the variable. Important to remember that absolute value piece. And the same is true as it was like the fourth root of x to the fourth. It still is the absolute value of x. So anytime we had a variable under a radical, we had to remember absolute value. Did we have to do it for cubes? No, because those actually do have cube roots. And it didn't matter if the variable is positive or negative, but for even roots, we did need to remember absolute value. So even roots and even indices, absolute value. I'm going to do that here too, again, thinking about who's going to win if we have large values of x. So this 3 is insignificant, and I'm sort of left with the square root of 4x squared. So I can clean that up just a little bit. That's going to be the absolute value of 2x. So the square root of 4 is 2, the square root of x squared is x, absolute value of it. And the denominator, we have the square root, we just have x. And so in this case, these x's, we'd have to be careful if this was negative. The numerator is always positive, but the denominator can change based on what values of x we're interested in. So here, for positive large values, we would just have positive results. So we can ignore that. We're just going to get 2. So again, that would be sort of a horizontal asymptote at y equals 2, graphically speaking. Now, what happens if we're going the other direction? Simplifying this, going to negative infinity now. Again, the square root of x squared simplifies to the absolute value of 2x. Our denominator is x. We can ignore the 3 because he's insignificant. All right, this is always positive. This x is negative. We're plugging in negative values of x. And so this would be a negative value in the denominator, negative large value, over 2 times a large value. So those large values would cancel out, and we'd have a negative underneath a 2. And so we get negative 2 for this particular limit. Kind of weird, but hopefully you'll get used to thinking that way. The Delta Math actually does a good job explaining it, probably better than me. So in this case, we have a horizontal asymptote at y equals -2. And this is a great one to graph and just look at. Remember, when in doubt, graph it out. Now, you're not going to be able to use your calculator on the AP test all the time, but now you can. And it's really good to reinforce what we're doing graphically, I think. So I've got 4x squared minus 3 over x, and I'm going to graph that in a standard window. And in fact, I'm going to go ahead and change the window because I've got all this extra space in the y direction. So I'm going to change my y minimum to say -3 and my y maximum to +3. It does connect in here. So there's no big gap. You can test that, like put in like 0.5. Oh, it is undefined. Oh, that's interesting. I was wrong. I didn't expect that. So always a good idea to test to see, hey, is there actually anything there? Because sometimes the graph, it just can't graph. So you do have to be a little careful. But you can see as, I'm going to change the window. We wanted negative, I'm going to go from like -100 to +100 in the x direction. So we can see sort of large values. Oh, cool. Interesting. All right. And so you can see when x is like -99, so a negative large value of x, you can see we're at -1.999. Yeah, -2. There you go. When we trace for a large value of x, like 100, you can see we're at 1.999, which is just about 2. Okay, and you can imagine if we got even larger, like 1,000 or 1,000,000, we would be even closer still to 2. All right, kind of interesting. Over here, I'm going to do a little cleanup. 2 is insignificant. We want to look at the leaders. Who's going to win? So this is 2x over the square root of x squared is the absolute value of x. The denominator is always positive, right? Always positive, but the numerator can change signs. So this is because we've got positive x values here. These are just going to reduce away, and we just get 2. Again, so horizontal asymptote at y equals 2. And here in the other direction, cleaning this up a little bit, using negative x values. Again, 2 is insignificant. The square root of x squared is the absolute value of x. And again, this denominator is always positive, but the numerator can change signs. So this is, let me say 2 times a large negative number over a large number. That's always positive in this case because of the absolute value. So the large number cancels out, but we have -2 left behind. Kind of weird. Again, sort of weird to think about that, but y equals -2. Weird, those are the same. I didn't plan that. I should have changed those numbers. Okay, hopefully you kind of understand. Read the delta math. It is actually very, very helpful, and they do a pretty good job explaining. So read when you get it wrong. Okay, I'm going to write that down. Read those explanations. I feel like I spelled that wrong. I don't know. Explanations. I have no idea. Folks, have a great day. Bye.